All right, this one is going to most likely be used with substitution because, as you can see, this guy right here is linear. This guy is not. If you have the choice, if you have a linear equation, go for it. I'm going to do this in red. I want to get x by itself. It does not matter. You just need one of the variables by itself. So I get x is equal to y plus 3. And what I'm going to do is I'm going to take this everywhere I see x in the original equation. I'm going to put y plus 3. So that's going to go right there. So I'm going to have, apologies. What I'm going to have is the thing that x is minus 2 squared plus y plus 3 squared equals 4. I'm going to combine some like terms. So this turns into y minus, plus 1 squared plus y plus 3 squared equals 4. So since these are not like terms at the moment, I have to do all the FOILing. So y plus 1 times y plus 1 is going to become y squared plus y plus y plus 1. There's a plus sign in the middle there. This is going to become y plus 3 times y plus 3. So I'm going to get y squared plus 3y plus 3y plus 9. And from up here, it equals 4. So go through, combine all your like terms. There's a y squared plus y squared, which is 2y squared. I've got y plus 3y plus 3y, which is 8y. We've got plus 1 plus 9, which is plus 10, equals 4. Now, this has to be factoring because I have a y squared and a regular y. So the thing that you need before you're allowed to factor is to make this equal 0. So I'm going to minus 4 for both sides. Get 2y squared plus 8y plus 6 is equal to 0. So what's left from here is to factor. Now I noticed that all of the numbers have something in common, so I'm going to pull a 2 out. I'm left with y squared plus 4y plus 3. Now I'm looking for a pair of numbers that multiplies to be positive 3, but adds to be positive 4. So that turns out to be positive 3 and positive 1. From here, you can set each of these guys equal to 0. So y plus 3 equals 0. We get that y is equal to negative 3. Y plus 1 is equal to 0. I get that y is equal to negative 1. So those are the y values of that equation. I'm going to create myself a little box over here. What we need to do now is we need to use those y values and plug them back into one of the original equations. It does not matter which, but of the two up there, you need to choose one of them. I'm going to use the second one because it involves less squaring. So x minus y equals 3. Well, what I know is I know that y is equal to negative 3. So I'm going to plug in negative 3. X minus negative 3 is equal to 3. This turns into x plus 3 is equal to 3. Subtract 3 from both sides, x is 0. So that coordinate point for that answer is x comma y, 0 comma negative 3. Those two go together. We used one to get the other. The other one, I also know that y is equal to negative 1. So when I plug this in, I can say x minus negative 1 is equal to 3. So that is x plus 1 is equal to 3. Therefore, subtract 1 from both sides is equal to 2. So the coordinate point for that guy is 2 comma negative 1, x comma y. And there are my two solutions for that.